Right. So now that you got a good understanding of what HSRP is, what it does, why it benefits us, and why it's beneficial for a network, we're going to actually use it to implement it into our network that we have here. So as you can see, we have a size 3 LAN network. We got our server LAN to the right. And we got our client LANs, or 2 client LANs to the left. As you can see, we got 1.1 for this router as a default gateway, and then 1.3 as a default gateway for this router. And with PCB being connected to 1.3 and PCA being connected to 1.1, our goal is to maintain connectivity to the server, .226. We all hate single points of failure, and that's why we have redundancy. But it seems like in this network, we can't use it. And that's because we do not have HSRP, which is being able to use different routers for different devices. Because PCB is default gateway is 1.3, because PCA's default gateway is 1.1, they are only able to use of that default gateway, which is that router. The benefit of HSRP is it allows us to create a virtual IP in between. And it's going to allow the routers to almost share it in a sense. Well, technically, they do share it. They're going to have the same IP. So really, whenever the chance comes where a copper connection, like for instance, this were to be cut or one or the other, then because they're to say the default gateway is that one IP, these end devices we be able to use either or. So that's what we're going to be implementing into our network, and pretty straightforward. So we'll go ahead and get into it now. Simply, actually, let's go ahead and test. Let's just see. Let's just see how it works first. All right. So we have PCB. We're gonna go ahead and ping 209.165.165.256. This is gonna be the first ping, so most likely gonna time out. Let's do it another time. Send it again. There we go. We have traffic. As I was saying, so go ahead and delete that connection. Now you can see we have lost connection. We're not getting replies anymore. So let me just connect that back again. So let's make this HSRP in order for it to work. Go ahead and get into router 1, get into CLI. First things first is we're going to get into our interfaces. So we're just go ahead and do interface. That's 0, 1. And then what we're going to do is we're going to turn on or enable our standby. So we do standby version 2. There we go. Let me just turn off these notifications real quick. Standby. So yeah, we just did standby version 2. After that, we'll simply add the IP, which will be standby 1 IP. Then we use 192.168.1.254. We use 254. We're gonna go ahead and make this router or router 1 our primary router or immediate router. So we'll just go ahead and put standby. 1 priority 150. Remember that priority is default at 100. Put a 150, we'll put it above, and we'll make it we'll give it an advantage over other routers to become the active router. Do a preempt command, and that will allow the router to immediately take back active status if it were to come to the network again. That does it for this port. Or it does it for this router, actually. Gonna show preempt. Yep. Just do a quick no, not yet. We're just gonna go into router 3. And we're going to do the same thing here. Get into our interface. So this interface will be interface gigabit 00. We'll do something standby version 2, standby 1, IP 2 168.1.254. All right, so we got that. We won't be putting in priority or preempt because we already picked a primary router. So we will leave this be, and we'll have this as the standby router. Go ahead, exit out of that. And I think that does finish it. That finishes us with our routers. We'll just do a quick show standby. Show standby. You show standby. We see our preempt. Preempt is disabled on this one. We have our priority for default. And we have our virtual IP address. That's what we're looking for right there. 254. So this IP address, as you could tell, it's the same IP address as before because we will be using this to share between the two routers. So that's a good sign. All right. Get out of that. Let's just do a quick show standby on this one. Do show standby. Do show standby. We can see that preemption is enabled on this one. Active router is local. And where is it? There it is. 192 virtual IP address. Awesome. There we go. It's looking good. So now we're just gonna simply assign our switches to these IPs. Configure terminal and then just simply default gateway 192.168.1.254. And then get out that. Same thing on this. Default gateway 192.168.1.254. Then now all we got to do, leave the addresses be. We're going to leave these addresses be. And all we're going to do is we're going to change these default gateways to 254. Change this one. 254. And that should give us the ability to use HSRP. So first of all, we'll just ping to test connection. Looks good, looks good. So since we're routing through router 1 at the moment because of its priority, we're going to actually try to cut that one off and try to use the standby. So let's see what happens when we use the standby. Go ahead. Go ahead and cut our active line. Ping. It's going to time out for a few. Now it should be in the process of switching over. Lost. Try again. And we have traffic. There we go. Takes a little bit because it has to switch over. Let's go ahead and try that on our PCA, see if it works. This was the PC that had 1.1 as default gateway. We have traffic. And there you go. That's HSRP on a network. That concludes our implementation. This shows how you can easily put in a extra redundancy into any network just using this simple protocol. So, yeah, thanks for watching.